to be on the entire or the right same page, meaning all of your answers agree, or at least you've had heated debates over why they don't. So if you haven't done that yet, you have 10 seconds. Number 121. Who has an answer choice for me? Chris.
A.
How come?
Because you plug in 2.
And what'd you get?
Negative 1/3.
Woo! Josh, I'd be paying attention.
Wait, can I get butterscotch?
Number 122. Who has an answer? Kyle.
B.
No.
D. I'm done.
Why?
Because the first one you can't like back to the top, so it doesn't exist.
Ooh. Well, okay. What happens when you plug in? Can you say it a different
0
way?
over 0.
No.
Oh, it's 2 over 0.
Which means it's
It's
a vertical asymptote, undefined. So technically, at this point, we'll say D and E. It might be an infinity, but D and E. Okay. Noah, keep going. Number 2.
That's 0 over 0.
That's 0 over 0. So how do you know that one doesn't exist? Uh-oh. Okay, that's a question mark. Number 3.
And it's f of x equals 3 and 0 since those are lines. I mean,
They're lines and they're coming in like this, and are they going to match it too?
no.
Less than? Or equal to? I totally drew that backwards. No. Okay, so hold on. Noah, by process of elimination, knew that 1 didn't work, knew that 3 didn't work, so the only option was letter D because it says do not exist. Josh, can you explain why 2 does not exist?
Oh, I was talking about wait, if I just split it up
to
that one?
x squared minus 9.
No, I was talking about I had.
Alright, he's in line, he's in line. Cameron, can you explain why this doesn't exist? No, that's not enough. Can anyone tell me why number 2 does not exist? Jonathan. You can have absolute value of 0. It is 0. Keep going, but how? Warren. No.
You can't divide by something? I'm just gonna leave. It's okay.
Well, I'm just saying, hold on. But the limit as x goes to 0 of sine of x over x, I can't factor either, but we memorize it to be 1. So I just don't want that to be the reason.
Oh, right, yeah.
Kyle.
Is it because like there's no negative like thing that goes from the left?
No, negative numbers can get plugged in. Kara.
When it's a graph, it's like they don't,
Oh, you know,
they're
I
not the same height.
Okay, can you tell from the graph before 0, where is it? Positive or negative?
Negative.
Uh-huh. And then after 0, what is it?
Positive.
Huh. How does that work algebraically? Ready? What's the number a little bit below 0? Just a little bit. Negative 0.001. Okay. Hold on. Gabby, hold on. If I plug in negative 0.001, what does the absolute value do? Positive. Negative 0.001 on the bottom stays negative. But it's the same number, so it reduces to be negative 1. And all the negatives will be that way. Because it'll be a negative with it turned positive. They're the same thing. They cancel out to be 1 or reduce to be 1, but they're going to be negatives. Now, as soon as you plug in a positive number, plug in 0.01 or 5 or 10 or 100. Positive stays positive, 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 positive 1. Not going to agree. Coming from one side, it's negative 1. The other side, it's positive 1. We'll talk about him more in the future. But D is the correct answer. Josh, did you already get your dum-dum?
No.
Okay, go ahead. How do you do?
C.
Why?
Because you make the top one. Well, first you plug it in.
And what do you get?
0.
Which means? Good, now what?
And then you would make the x, or yeah, you write the limit. And then you do x to the power of 2 minus 9 times x to the power of 2 plus 9. And the bottom you leave the same. And then you write the limit again. And then you write x minus 3 times x plus 3 times x squared plus 9. And then you would cancel out the x minus 3's and then just plug in.
And when do you plug in? 6 times
18.
18 is?
108.
Nice. I have no idea. What kind do you want?
A good one.
You've been working so hard. Mystery?
Cotton candy. Is there cotton candy?
Butterscotch. Butterscotch.
Chris, what do you want? Butterscotch? Oh, you already have it in here. Oh, too bad. All right, homework. Turn to the front. Well, first, any quick questions on APMC? All right, spiral. Turn to the front. Section 1.3. Let's check those evens. Remember, unlike pre-cal, can we go over every single even odd question you have? No. But we'll go over the even answers, see if we get right or wrong. Color pen, out, not black, not gray, not light tan, not a highlighter, not yellow. Something visible that you can correct with. Where are we at? This one? 2, 24, 36. I'll get it started. Here we go. Whoop. Number 2. Now, wasn't A an approximate, kind of? Exactly, it'd be 2.4. Approximated, it'd be 2-ish. Sound good? 2-ish, 2.5-ish. B. 2. You should do that one exactly, but you had to multiply by the conjugate and simplify. Or see this as root x plus 3, root x minus 3. Anyway, keep going. I lost track. What's my next one? Thank you. Too much fun. 24. Hey, look, I'm still giving you trig to remind you it's important. 0. Number next one.
36.
I said 86. Wow. Did you guys get -1 or did you stop?
-1.
Why -1? There's an E. I can make him to the -1 power, and then whoosh, -1 comes down, the rest cancels out. Right? Allen and E, remember they undo each other. If you have the wrong answer, correct it. If you have time, you can go further. Number next one. 44. He has a lot going on. And technically, he was from that long table of properties that said, if you know the limit of f of x is 27, just do the operation. Plug it in, 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 plug it. Okay, you got it? Check the answers. But as you do, how on earth is 27 to the 2/3 9? Maybe explain that to me? Yeah.
Because you can make it like that radical with the 3 that's on the thing.
And what goes up here?
Yeah, then you can put a 3 there.
Uh-huh.
And then you can square that entire thing.
Uh-huh. Do you have a mental math way of doing that without having to put in 729 into your calculator? Who has a mental math way? Josh? No. Noah? How do you do it mental math?
In my mind, it just works as like 999, 9, and that's that.
Oh, okay, but you had to like think of all the different 3's and then group them in nines. Okay, hold on, Josh, keep going.
I don't know if it'll work in like other circumstances, but for at least this one, you can take the cube root of 27, that's 3, and then multiply it by 2.
Uh-huh. And I'm not going to say 2, I'm going to put it this way. You can say squared means there's 2 of them, and then the cube root of 27 is 3, and the cube root of 27 is 3, and now we can get the 9. That's one way. And the other way is before we even went to the radical to say 27 is 3 what? What happens when we do this? Multiply the exponents, 3 squared is 9? That's cheating. Anyway, not really. Okay. 58. We graded those, yeah? Okay. 1/4. Let me give you a second though. Hold on. 63 is odd. Oh. I get it? Almost. 1/16, but we'll get there in a second. Who is this and where on earth did he come from? Conjugate of the part with the square root, and the only sign that flipped was the middle sign, which doesn't look like the middle because this is big, but that's okay. I still have the square rooty thing, as one term, the 2 as another term, there's a minus, make it a plus. And what do you have to be super careful of? Not doing stuff illegally. So on top, now this is a huge jump they took that some of you can make, but some of you can't. What happens when you FOIL the top only? Because the bottom just mushes together, right?
Square root, get rid of it.
Square roots are canceled, because this squared goes away. Outer and inner cancel, and what do you get as last?
-4.
That's how you get x minus. Remember, first, but square root squared, or times itself, is just alone. Plus 2 square root minus 2 square root cancels. That's the point of the conjugate. Minus 4. 1 minus 4 is 3. Now I am totally allowed to whoosh that out of there. And then plug it in, 1/4. Going over that one just because he's a little confusing. But you guys at least wrote down 1/4, right? If you didn't get that one. Number 62, negative 1/16. What would you have multiplied top and bottom by? Summer packet, complex fractions. Ugh. Common denominator is what I would do. So I would take this puppy. Just because a few of you guys didn't have me last year, so just to make sure we're kind of all on the same page, even though you all have the same summer packet. Take the little baby denominators. Multiply top and bottom by the 2 together. When you multiply the top, you distribute. What happens if I multiply 1 over x plus 4 times 4x plus 4? What cancels? And what's left? 4 times 1 is? Distribute again. Everything is still here. It's distributing. What happens to the 4s? And what's left? Careful. Did you put your parentheses or did you kill a seal? Don't do it. Are you rewriting your limits every single time until you do the final plug-in? Ah, yes you do. It's like randomly taking a square root out of a problem without squaring both sides. So illegal. It ruins your whole solution. Distribute the negative in. 4's cancel. You just have negative x over x. The x's cancel. And you end up with, wait, what?
The rest of the fraction, you forgot to multiply
Bottom.
Oh, I just left the entire thing off. Well, that's sad. The x's still cancel, but who's still left? Poor little 4. Negative 1 is left on top. 0 makes 4 times 4, 16. Ugh. What's the answer? Final answer, 2x. Remember, if you don't like 2x, sorry, no. The answer is 2x. If you don't like it, sorry, too bad. But if you don't like delta x, what did you see in homework that can replace delta x and make the problem look nicer? Didn't some of the problems have it? Not delta x, but it had something else. H. You could also let delta x equal h, and you can put h's everywhere and not have to deal with the whole weird delta xy thing. And h's, you're like, oh, of course h and x are different. Delta x, some of you, it's hard to realize that delta x and x are different. They are. But if you want, it would work just as well if you just had h's everywhere instead. The name of the game, it was 0 over 0. Keep going. It's a difference quotient. You FOIL properly, don't kill a puppy, and you simplify to cancel out after factoring. Plug in, h is 0 because you didn't stop writing the limit, and you get 2x. We're not plugging in for x. Who are we plugging in for all along? H, or delta x. That's the only part that goes away. Do we have any more evens? 80. 80. Is the last one?
Yes.
Yeah. So number 80. Oops, I passed it. Final answer is 8. But why did I get so many questions in 0 periods, and yesterday after school, and yesterday at lunch, and yesterday during 7th period?
Because of the E.
Because of the E. You don't like them. But e to the 2x is the same thing as e to the x squared. So that's a perfect square. That's a perfect square. We can do difference of squares. Bam, bam. Plug it in, plug it in. And anything to the 0 power is 1. So 1 plus 1 is 2. 4 times 2 is. Couple more seconds. That's our last even. If you have questions on odds, please don't just like shove them under a blanket and pretend they're not there. Come talk to me. Before school on Wednesdays, after school, lunchtimes. Usually I had a meeting today. I'm sorry. But most other lunchtimes besides Monday. Monday is back. All right. 2 more seconds. But ready, set, we're going into our composition book, section 1.4. Go. I think, and it's chapter 1, I believe there are 6 sections. And if there are 6 sections, that means we are almost 2/3 of the way done, which means a test is coming soonish. Soonish. The calendar is a little bit off because as I was going through period 1 today and as I was actually just finishing up notes and whatnot to be ready for today, last night and this morning, we can't do 1-4 in one day. We can't do it. It's too important. So there's too much stuff to practice. So we're starting 1-4 today. Some of you are happy because that means homework is not due tomorrow like the calendar says. It's due on Tuesday. Because Friday is Spirit Day. Monday is Labor Day. Now pause.
Beautifully planned.
Right? Isn't that nice?
Yes.
However, wait, eyes on me. Focus box. I'm missing some people. Eyes on me. Look up. Look up. Eyes on me. Thank you, thank you, thank you, thank you. Cameron? If you wait and don't touch homework 1.4 until Monday night or Tuesday morning, even worse. How much recall are you going to have from what we talk about today and tomorrow? After Spirit Day and Labor Day and like, yay, I have a really long weekend.
Absolutely perfect.
It's not going to be absolutely perfect unless you rewatch all the lectures, and that's an hour and a half out of your night that you're cramming all the rest of your homework into. So, instead, we're going to start homework tonight. We're going to keep working on it tomorrow a little bit if we're not decorating shirts, etc. And then we're going to go ahead and keep working on it so that we don't forget calculus over the weekend. Sound good?
Yes, ma'am.
Okay. Let's go.
What's that section called?
I know I should not need to give you that advice, and yet some of you are like, oh, so true. And I get it. I procrastinate. Or do you like this not enough?
It's not procrastinating. Just say you're still procrastinating.
If it's something new, like today, and tomorrow's going to be some of it, you need to practice it right away, or else it grows wings and flies. But in math, photographic memory is not always enough. The problems change a little bit every time. Okay, here we go. Section 1.4, I almost said 5. 1.4, continuity and one-sided limits. Nice thing is, some of homework is just doing one-sided limits that we've already started working on. But, much more. Here's what I want you guys to do. As you start in your notes, you are graphing these first 4 graphs, and I want you to think through the following 2-ish questions. I might add to it in a bit. As you graph them. First question. Are they continuous everywhere? If they are not, where is the discontinuity? Ooh, sorry, 3 questions. And why does it have a discontinuity there? As you're drawing these first 4 graphs, or these 4 graphs I should say, I want you to ask yourself the question, are each of these continuous everywhere? If they're not, where is the discontinuity? Could be more than one place. And why is there a discontinuity there? Keep going. You don't have to write anything with those questions, just think about them as you write. little more time to graph. But as you keep graphing, answer the question, are they all or are each of them continuous everywhere? Are any of them continuous everywhere? And as you look at each of the four, where does the discontinuity in these examples lie? At, say it again, at x equals c. Okay, keep writing. I'm just putting down each of them are discontinuous at. So we've answered two questions. None of them are continuous everywhere. Each of them strategically has a discontinuity at C. My final question is how are they that was coming out wrong. How are they discontinuous? Why at C is it not continuous? Back in the olden days when we talked about continuous as you finish your sketches, what was like the super silly way, maybe not silly, elementary way of thinking? Elementary doesn't mean literally in elementary, it just means like earlier before we knew any better. What was the easy way to think about continuous? Josh?
If you don't lift your pencil.
Right, if you can draw the graph without lifting or having to lift your pencil. For a whole, you'd have to, now, could we cheat and like, and then like keep going? Yes, but if I was tracing it, wouldn't you have to be like, right? You have to pick up your pencil. Or a vertical asymptote, same thing. You can't literally draw it forever and somehow connect to the other forever. It doesn't work. You have to pick it up, right? Or a jump. You have to go and then you have to, still have to, there we go. And then we have to keep drawing. Like you have to pick up your pencil. If I ask you after today, on a quiz or a test, the definition of continuous, not having to lift up your pencil doesn't count. It's a great way of thinking about it. Silly shortcut, but doesn't count. Okay, what's another way of talking about it? If I was to ask you definition of continuous right now and the pencil thing doesn't work, what could you say instead?
No breaks.
No breaks, no holes, no vertical asymptotes. Maybe you'd say that. And that's a good description. Still kind of fits in the whole pencil category. It's not going to work. I'm going to give you probably no points. So we need to figure out what technically is going on. Now, I don't want to hear it quite yet, but keep thinking with me. I'm going to ask you a few questions. Ready? For each graph. Let's start with the first one. Does f of c exist?
No.
Why not? Go up C and ask, are there any y values? And not just is there a hole, but there's no other points, right? So f of c does not exist. Huh. Let me ask you a second question. Does the limit as x approaches c of f of x exist?
Yes.
Yes. Because we've learned as long as they're headed to the same direction, even if the diner burned down or is locked, they can't get in, the limit still exists. Let's go to the next one. Does f of c exist?
Yes.
Yes. Why? Because there's a hole. Doesn't matter, there's a point. F of c exists. Does the limit as x approaches c of f of x exist? No. Oh, so maybe just one of these being wrong is enough and it's discontinuous. Either f of c doesn't exist or the limit doesn't exist, right? How about the third graph? Does f of c exist?
Yes.
Yeah. There's a vertical asymptote. I don't care, there's a point. Now, hold on. Can someone just help me really quickly? What is the only way for a function with a vertical asymptote to have a point? What's the only way that can happen? Can that naturally happen? Or has someone manipulated something? Okay, so what happens when someone manipulates something? What have they made?
Exception.
Kind of. They've restricted different pieces.
Piecewise.
Piecewise.
Yeah, Kyle.
What? With the piecewise, they say, oh, fine, it's this for this, and it's that for that. And you're like, oh, you're just totally messing with things, right? They're playing God with equations. That's rough. But either way, sometimes it's applicable and it's necessary. Is there an f of c? Yes. Does the limit as x approaches c of f of x exist? Okay. Tricky question.
Well, it is.
It's infinity. We can kind of debate. Technically, no. Josh was right.
Not really.
Technically, no. But it kind of, sort of. Here's a bigger way. Do these two agree? Going to infinity and a point.
No.
No, they don't agree. And you're still like, well, the limit didn't work. Okay, kind of. I want you guys to finish off the last one. Does f of c, let me give you a second. Don't answer out loud. I want you to put an X or a check. And think about, why is it discontinuous then? Noah, what was your...
On the AP exam, would it be D&E or infinity?
Infinity. If they were just asking the limit question.
Okay.
But
I feel like choose one and make it so that you can't use the other.
right, they would never have, for that problem, that limit, they would never have an infinity and a non-existent. At least that I've seen. It
Okay.
would either be infinity or non-existent as an answer choice along with some constants or something. Okay? But keep that one in mind just in case we do happen to see an exception to that. But I can promise it would be infinity. But in some sample AP books, like Barron's or other ones like that, they might say non-existent instead. What'd you guys do for f of c? Check or X?
Check.
Oh yeah, there's a point. I see him. He's right there. How about the limit?
Check.
Oh yeah, it agrees. Ah, that just blows the rest out of the water. Continuous was one of them was wrong, but both of these are right.
What if they're both wrong?
Both wrong, well that's like doubly discontinuous. But hold on, why is he discontinuous? They're both right.
2 points, because
Not 2 points though, that's a whole. But you're along or you're on the same or the right track. The whole and the point do not agree. Okay? So something has to be wrong, but there are 3 somethings that we have to check. Does f of c exist? If it doesn't, haha, it's discontinuous. If it does, I have to keep looking. Does the limit exist? If it doesn't, discontinuous. Uh-oh, but what if they both are right? Do they agree? Because they both should be heights. Do they agree?
No.
Discontinuous. If they agree, he would be in there and it'd be continuous and we're fine. So, does it make sense then, from now on, we have to describe the definition of continuous as following. The definition of a continuous function. Our definition is, a function is continuous at x equals c if the following 3 conditions are satisfied or are met or are true. 1, is f of c defined? Is it real? Does it exist? 2, does the limit, we have to specify. This font doesn't let me do it, so I'm just throwing it in. Does the limit as x approaches c of f of x exist? And finally, does the limit as x approaches c of f of x coincide, equal f of c? And for normal, equations given to you or functions given to you algebraically, I ran out of space, but algebraically, aka if a function is given to you, you have to think through these 3 things. The normal function is given to you. If a graph is given to you, or a piecewise function, I can't spell piecewise. Piewise? Not pi yet. There's another way of writing it. Means the same thing, has all the meaning, I just said that, of the other one. But it's kind of written a little bit simpler. With a graph or piecewise, do you guys see how this is the exact same thing? What does it take for a limit to exist? What What has to be true of the two one-sided limits? They must agree. So if you're thinking through a graph, or if you're thinking through a piecewise function, the easiest way to think about continuity is to think about those three conditions. Give me a second. But technically, as a note at the bottom, if something fails, there is some sort of discontinuity at x equals c. It's kind of more of a like, oh duh, but still kind of important. In calculus, some definitions are kind of important. Some definitions we just have to understand. And some definitions, I am sorry, but we must have them memorized. Why does he have a box around him?
That's the point.
Because he's forever number 4. We need to have a forever quiz soon. We're getting too many. But the first 2 were review. The third one was just like, what, 3 things? 2 that are most important. 4th one is a definition. 5th one is kind of another definition. It's a theorem. We better have a quiz after that. And some of you are like, forever quiz? You're going to actually make sure we memorize? Yeah, How could a quiz be set up? Get out a half sheet of paper. Get out a full sheet of paper. Oh. I could ask you something like, sketch the graph of y equals e to the x. Or, here's a graph. Who is he? Cube root of x. Maybe that wasn't on there. How about this one? I could put that one. Who is he? 1 over x squared. I could ask something like, fill in the following limit. The limit as u approaches 0, sine of u over u equals, and you should say?
1.
And I could say, state the entire definition of continuity.
Easy.
Whole thing? Whole thing. Just the 3? Nope. Just the box? Mm-mm. The whole thing. So some of you are like, oh, this is like an actual studying, memorizing. Yeah, it is. All right, let's keep going. Let's keep going. Since we're talking about discontinuities, let's go ahead and label them. Let's describe them. Let's label them. Let's describe them. Ever since, I don't know, forever? Just kidding. A few years. We've talked about removable and non-removable. Blah, blah, blah. Discontinuities. Removable. Those are holes. But holes that can be simplified. You're like, wait, not all holes? Out. Only holes that can be simplified out. Now, why don't I just say factored out? Is factoring the only thing, the only way you keep going? Multiply conjugate, simplify complex fraction, use trig properties to simplify, etc., etc., etc. So I'm just saying, holes that can be simplified out. Quick example would be something like, which would be some sort of cubic function over x minus 1-ish, x minus 2-ish. You could factor and you could cancel. Holes that can be simplified out. Non-removable. Could be a jump. Remember, this doesn't define continuity. This just describes what happens if I have a discontinuity. A jump, a break, or 2 words. Non-removable discontinuity. What is it?
Vertical asymptote.
Vertical asymptote. It's not a hole, it's a vertical asymptote of basic functions like we saw last year. Aw, stink, those were basic? Well, no, some were harder than others. Let me go ahead and show examples of this one. What if I was to do, let's see, something like Jump. Only possible if you have a piecewise function, yeah? Because it's this one, excluding that x and putting it somewhere else. Break, something like maybe absolute value of x over x like we saw this morning. Oh my goodness, a little bit ago. That was a jump in time. Vertical asymptote. They could even be agreeing, but still non-removable. Agreeing, disagreeing, agreeing up, agreeing down, doesn't matter. All of those are non-removable. Why? You can't factor them out. You can't simplify them out. They're stuck. Okay? So, homework. What's something that can show up? Well, first of all, look back at the definition of continuous. They could just have you practice in one-sided limits so that you get down or practice, understand what it means to come from the left, come from the right. Homework hasn't really shown you that yet. So this section, you're going to be practicing one-sided limits. But then they're also going to be asking a very important question. Discuss the continuity of and give you lots of different examples. But before we get there, let's talk about, just to make it a little bit easier, a few hints. Common functions that are continuous everywhere, aka no discontinuities. Help me out. What's a common function? And don't tell it to me specifically, but the name of it. What's the name of a whole category of functions that will be continuous, always, everywhere? Huh?
Quadratics.
Quadratics, linear, be broader.
Polynomials.
All polynomials. All regular polynomials. Whether first degree, linear, second degree, quadratic, third degree, cubic. All polynomial functions will be continuous everywhere. What does that mean? If you see x raised to a power plus this, plus that, plus the other, no square roots, no denominators, no logarithms, no, wait, domain problems, we remember those. Maybe not. If it doesn't have a domain problem, it's probably good. All polynomials are totally good. What else? Uh-oh. How about exponential? Why are they good? Think about e to the x. Do you remember what he looks like? He goes on forever and ever that way and forever and ever that way. He's fine. Exponentials are good. Which one? Radicals are good, but only in their domain. Rationals are only good as long as the denominator is not 0. Logs are only good on this side or that side of their vertical asymptote. Trig is only good. Wait, which trig are good everywhere? How about sine of x, cosine of x? Sine and cosine alone are fine. All the rest, not so much. But however, Noah did say, well, what about radicals? Well, they're good everywhere in their domain. Rational, they're good everywhere, as long as the denominator is not 0, in their domain. Tangent, cotangent, cosecant, secant. They're good everywhere in their domain. So we kind of have to remember our domain problems to be able to say where they're good and where they're not. Does that make sense? Okay. This bottom part, I don't know if it's a huge deal, but long story short, if you know that something is continuous and you multiply, so hold on real quick, f and g are continuous. If we know that something is continuous at a certain place, multiply that something by a number, he's still continuous, no big deal. That's what this is saying. Add two continuous functions together, like x squared plus sine of x. Still continuous. Both the pieces are. Add them together, no big deal. Subtract them, no big deal. Product. Multiply two continuous functions together. Still continuous. Quotient. Divide two continuous functions. They're still continuous as long as, you guys should know the exception, the bottom's not 0. Multiply by a number, good. Add two continuous things together, good. Or subtract, good. Multiply, good. Divide, good, as long as the bottom's not 0. Now, remember, we're coming back to this tomorrow, so don't stress, put down your pencil. Let's talk it out just a little bit. Question, continuous everywhere. No. Continuous everywhere but
0.
x equals 0, which is removable or non-removable? I can't factor in non-removable, etc., etc., etc. Quick. If you start homework tonight and you see piecewises, my preference would be to wait and stop there. My preference would be to wait until I can talk about it more tomorrow. Bye, guys. I'll see you later. Later, skaters. Happy 7th period.